If you've taken a DNA test and discovered Dutch ancestry, you might be surprised to learn that your genetic heritage tells a story far more complex than the simple Germanic label most companies assign to your results. What if the conventional understanding of Dutch genetic origins was incomplete? A comprehensive study of Dutch Y chromosome distribution sent shockwaves through the genetic genealogy community, revealing patterns that challenge decades of assumptions about who the Dutch really are. The research team had expected to find a relatively homogeneous population reflecting the small size and supposed genetic unity of the Netherlands. Instead, they discovered something extraordinary: significant genetic substructures that mapped directly onto geography, with different regions showing distinct ancestral signatures that told stories of ancient migrations, medieval invasions, and prehistoric transformations that most Dutch people had never heard of. The implications were staggering. For the first time, scientists could trace the exact genetic threads that wove together to create the modern Dutch population, and the picture that emerged was nothing like what anyone had expected. But perhaps most shocking of all was what they discovered about genetic continuity. Unlike other European populations that showed dramatic genetic upheavals during major historical transitions, the Dutch displayed a remarkable stability that seemed to defy the tumultuous history of the Low Countries. How had a population living in one of Europe's most contested regions maintained such genetic integrity through centuries of foreign occupation, massive population movements, and cultural transformations? The answer would force geneticists to completely rethink their understanding of how populations persist through historical trauma, and reveal that the Dutch genetic story was both far more ancient and far more resilient than anyone had imagined. 300,000 years ago, something unprecedented was happening in the marshy landscapes of what would become the Netherlands. The earliest hints of human presence weren't left by our own species at all, but by Neanderthals who had somehow navigated the treacherous Ice Age terrains to establish communities in the Low Countries. The Krijn skull fragment, dredged up from the North Sea off the coast of Zealand, represented more than just archaeological curiosity. It was evidence that these ancient steppes and wetlands had been drawing human populations for longer than anyone had imagined. These early Neanderthal communities crafted sophisticated Mousterian tools and established seasonal camps that would be submerged by rising sea levels tens of thousands of years later. But their genetic legacy poses a fascinating puzzle. Modern Dutch people carry approximately 2% Neanderthal ancestry, matching other European populations. Yet this percentage tells a story specific to the Netherlands. The Neanderthal DNA present in Dutch genomes wasn't just a random inheritance from distant ancestors. It represented specific episodes of interbreeding that occurred right here, in the caves and river valleys of the ancient Low Countries. The implications are profound. When researchers examined the specific Neanderthal lineages present in modern Dutch DNA, they found signatures that could be traced to particular geographical regions and time periods. This wasn't just ancient admixture filtered through countless generations of migration and mixing. This was evidence that the lands that would become the Netherlands had served as a specific contact zone, where Neanderthals and early modern humans met, mingled, and left genetic traces that persist today. How is this possible? The answer lies in the unique geography of the Low Countries during the Ice Age. The region served as a corridor between the frozen expanses of northern Europe and the more temperate refugia to the south. As populations moved back and forth following the advance and retreat of glaciers, the Netherlands became a crossroads where different human lineages encountered each other repeatedly over tens of thousands of years. Around 40,000 years ago, anatomically modern humans began arriving in Europe, armed with sophisticated Upper Paleolithic technology that would revolutionize the continent. In the Netherlands, these early modern humans left clear archaeological evidence at sites throughout the region, particularly along river valleys and coastal areas that offered rich resources and strategic positions. These Paleolithic peoples belonged to specific mitochondrial DNA haplogroups, primarily U5 and U2, and Y chromosome lineages like I2 that would become characteristic of European hunter-gatherers. They were skilled toolmakers who developed regional variations of blade and spear point technologies, and they successfully adapted to the challenging environments of Ice Age Europe. For thousands of years, they were the sole human inhabitants of the Low Countries. But here's where the Dutch genetic story takes a mysterious turn. When modern geneticists examined contemporary Dutch DNA, they found only trace amounts of these ancient European hunter-gatherer lineages. The dominant genetic signals came from completely different sources. It was as if the original inhabitants of the Netherlands had simply vanished, replaced by peoples with entirely different ancestral origins. Where did they go? The answer would revolutionize our understanding of one of history's most important transitions, the Neolithic Revolution. Unlike the violent population replacements that characterized much of European prehistory, something far more subtle and complex had occurred in the Netherlands. The hunter-gatherer lineages hadn't disappeared entirely. They had been absorbed into new populations through a process of gradual genetic and cultural integration that was unique in its sophistication and completeness. Rather than conquest or displacement, the Netherlands had witnessed one of Europe's most successful examples of cultural and biological synthesis. As the Ice Age ended and sea levels rose, the Netherlands transformed into a vast wetland paradise that would prove irresistible to Mesolithic populations, seeking rich and reliable resources. The Swifterbant culture, which flourished between 5,300 and 3,400 BC, represented something unprecedented in European prehistory, a sophisticated hunter-gatherer society that had learned to thrive in one of the continent's most challenging environments. These weren't primitive nomads struggling to survive in marginal landscapes. The Swifterbant people were master wetland specialists who developed complex seasonal strategies involving fishing, fowling, gathering, and hunting across diverse ecological niches. They lived in substantial settlements along creeks and river dunes, created sophisticated pottery traditions, and maintained extensive trade networks that connected them to agricultural societies hundreds of kilometers away. Recent genetic analysis has revealed something remarkable about these Mesolithic inhabitants. They displayed extraordinary genetic diversity, with some individuals showing pure hunter-gatherer ancestry, while others had already begun incorporating farmer-related lineages. This wasn't random admixture, it was evidence of deliberate cultural exchange and selective integration that would set the stage for everything that followed. The Swifterbant people carried mitochondrial DNA haplogroups typical of Western hunter-gatherers, including U5, U4, and smaller frequencies of H and other lineages. Their Y chromosome profile was dominated by haplogroup I2, which would become a persistent signature in Dutch genetics. But most importantly, they had begun experimenting with animal domestication and plant cultivation, making them pioneers of agricultural innovation in Northern Europe. This transition wasn't driven by population replacement or technological diffusion from the south. Instead, the Swifterbant culture represents indigenous innovation, European hunter-gatherers who independently developed agricultural techniques while maintaining their traditional lifestyles and genetic integrity. They had created something entirely new, a hybrid economy that combined the best of both worlds. Around 5,300 BC, farmers began arriving in the Netherlands from the southeast, bringing with them a revolutionary package of technologies, crops, and livestock that would transform the region forever. But contrary to popular assumptions, this wasn't a mass migration or violent conquest. The genetic evidence reveals something far more nuanced, a gradual process of integration that unfolded over centuries and involved complex negotiations between indigenous hunter-gatherers and incoming agriculturalists. The earliest Neolithic individuals associated with the Swifterbant culture show remarkable genetic heterogeneity, with some individuals entirely descending from hunter-gatherer populations, while others had 60 to 70% of such ancestry, and still others showing 35 to 45% hunter-gatherer ancestry. The farmers brought mitochondrial DNA haplogroups N1A, T2, H, and K, along with Y chromosome lineages G2A and J2 that originated in Anatolia thousands of years earlier. These genetic signatures spread gradually through the Dutch population, not through conquest but through intermarriage, adoption, and voluntary cultural conversion. Why did the hunter-gatherers allow themselves to be genetically absorbed? The answer lay in the undeniable advantages of farming: reliable food supplies, larger population sizes, and the ability to support specialized crafts and complex social hierarchies. But the transition wasn't one-sided. The farmers had to adapt their techniques to the unique wetland environments of the Netherlands, learning from indigenous knowledge about local resources, seasonal patterns, and landscape management. The result was something unprecedented, a new population that combined the genetic heritage of ancient European hunter-gatherers with the cultural and technological innovations of Near Eastern farmers, creating a unique synthesis that would become characteristic of Dutch prehistory. By 3200 BC, the genetic foundation laid by Neolithic farmers had given rise to something extraordinary: sophisticated maritime civilizations that had no parallel north of the Alps. The Netherlands had become home to complex societies that built monumental structures, maintained extensive trade networks, and developed cultural traditions that would influence all of Northern Europe. Where had they come from? The genetic evidence provides a clear answer. They hadn't come from anywhere. These maritime peoples were the direct descendants of the local Neolithic farmers, with virtually no outside genetic influence. Modern genetic studies show that Dutch people possess Y-DNA haplogroups in approximately the following frequencies. R1b at 53.5%, by far their most prevalent Y haplogroup. I1 at 18.5%. But this genetic stability masked a period of extraordinary cultural innovation. The early Bronze Age inhabitants of the Netherlands had developed sophisticated metallurgical techniques, complex burial practices, and artistic traditions that rivaled anything in contemporary Europe. They were accomplished seafarers who traded across the North Sea and maintained diplomatic relationships with societies as far away as Britain and Scandinavia. The secret to their success lay in their unique geographical position. The Netherlands sat at the centre of Northern European trade networks, with access to both continental and maritime routes. This allowed them to accumulate wealth, ideas, and technologies while maintaining their cultural and genetic independence. They had created fortress landscapes that were simultaneously cosmopolitan and closed. Yet this genetic isolation was about to end. Around 2500 BC, new peoples would arrive, bringing revolutionary technologies and cultural practices that would transform the Netherlands forever. The arrival of the Beaker culture around 2500 BC marked the most dramatic genetic transformation in Dutch prehistory. These weren't just new cultural traditions, they represented a fundamental shift in the human population of the Low Countries. Beaker, individuals from Germany and the Czech Republic, had high proportions of steppe-related ancestry, showing that they derived from mixtures of populations from the steppe and the preceding Neolithic farmers of Europe, with Y chromosome composition dominated by R1b, M269. But the Dutch story was unique. The British Beaker groups were most closely related to individuals from the Oostwood-Tweethorn site, in the West Frisia region of the Netherlands, with both groups presenting almost identical percentages of steppe-related ancestry. This suggests that the Netherlands had become a staging ground for one of European prehistory's most significant population movements. The Beaker transformation brought new Y chromosome lineages, particularly R1b, U106, which would become the dominant male lineage in the modern Dutch population. But it also brought revolutionary innovations, advanced metallurgy, and most importantly, Indo-European languages. These technologies didn't just change how people lived, they fundamentally altered the social and political organization of Dutch society. The corded Ware culture, which preceded and influenced the Beaker phenomenon, originated from the westward migration of Yamnaya-related people from the steppe forest zone, bringing ancient North Eurasian ancestry into Western Europe. In the Netherlands, this transformation was more gradual than elsewhere, involving complex interactions between incoming steppe peoples and established local populations. Genetic evidence reveals that the Beaker transformation wasn't a simple conquest. Instead, it involved selective integration of steppe-related males with local women, creating new hybrid populations that combined the best of both genetic traditions. The result was a population that was simultaneously innovative and conservative, adopting new technologies while maintaining connections to ancient local traditions. During the Iron Age, the genetic foundation established by Beaker populations gave rise to the Germanic tribes that would become legendary in Roman accounts: the Frisians, Batavians, Canaanophates, and others. These weren't foreign invaders, but the direct descendants of Bronze Age populations that had been living in the Netherlands for over a millennium. Recent Y chromosomal studies have found evidence for genetic geographic population substructure in the Netherlands, with several Y haplogroups demonstrating significant clinal frequency distributions in different directions. This structure reflects the tribal organization of Germanic society, where different regions maintain distinct genetic and cultural identities while sharing common languages and traditions. The dominant Y chromosome lineage was R1b, U106, a branch specific to northwest Germanic populations that had evolved from the earlier Beaker, R1b, M269. This lineage reached its highest frequencies in the coastal regions of the Netherlands, particularly in areas that would later become associated with Frisian culture. I1, another characteristically Germanic lineage, was most common in the northern and eastern provinces. The tribal period was characterized by genetic consolidation rather than continued immigration. Local populations grew in size and cultural complexity while maintaining their essential genetic character. Trade relationships with Celtic and Roman societies brought new ideas and technologies, but had minimal impact on the underlying population genetics. This genetic stability would prove crucial during the coming centuries, as the Netherlands faced its first major challenge from organized state societies. When Rome encountered the Germanic tribes of the Netherlands in the 1st century BC, the genetic consequences were far more limited than the cultural impact might suggest. Roman occupation of the southern Netherlands brought Mediterranean settlers, soldiers, and slaves who carried Y chromosome lineages like E1b1b and J2, along with mitochondrial DNA haplogroups typical of southern European populations. Studies show that modern Dutch populations carry approximately 4.5% E1b1b and 6% J2, lineages that ultimately stem from the Middle East and Mediterranean regions. But these frequencies are modest compared to the genetic impact of earlier prehistoric migrations, and they were concentrated primarily in urban centres rather than rural areas. The pattern was similar to what occurred in Roman Greece. Cities became cosmopolitan melting pots, while the countryside remained genetically stable. This created a two-tier system where urban Dutch populations showed greater genetic diversity, while rural communities preserved ancient Germanic lineages with minimal admixture. Roman administration brought new forms of social organization, architectural styles, and economic systems. But it also brought Christianity, which would eventually transform Dutch cultural identity, while leaving the underlying genetics largely unchanged. The genetic evidence suggests that Roman rule was primarily an elite phenomenon that affected political structures without fundamentally altering the demographic composition of the Netherlands. This pattern of elite dominance without mass population replacement would repeat throughout Dutch history, allowing ancient genetic signatures to survive even dramatic political transformations. The fall of Roman authority in the 5th century created opportunities for Germanic peoples to expand their territories and consolidate their power. In the Netherlands, this period saw the rise of Frankish influence, bringing West Germanic peoples who were closely related to the existing population, but carried distinct cultural and political traditions. The Franks represented genetic consolidation rather than replacement. Modern Dutch people show strong affinities to ancient Frankish remains found in northern France and Belgium, but this reflects shared ancestry rather than migration. The Frankish period was characterized by political unification and cultural synthesis that built upon existing Germanic foundations. Y chromosome analysis reveals that this period saw the continued dominance of R1b, U106, and I1 lineages, with only modest additions from other Germanic sources. The Frankish expansion was primarily a political and cultural phenomenon that involved related populations, sharing similar genetic backgrounds. But the Frankish period also established patterns of political organization and cultural identity that would persist for centuries. The Netherlands became part of larger Germanic confederations, while maintaining distinct regional characteristics that reflected deeper genetic and cultural continuities. This consolidation would prove essential during the coming centuries, as the Netherlands faced new challenges from Scandinavian seafarers and other external forces. The Viking Age brought new genetic influences to the Netherlands, but not in the dramatic fashion that popular culture might suggest. Rather than massive raids and settlements, the genetic evidence points to more subtle forms of contact involving trade, intermarriage, and gradual cultural exchange. The Viking influence was most pronounced in coastal areas, particularly in Frisia, where Scandinavian raiders and traders had established regular contacts. But rather than conquering and replacing local populations, the Vikings integrated into existing social structures through marriage alliances and commercial partnerships. Mitochondrial DNA evidence shows modest increases in haplogroups typical of Scandinavian populations. But these changes were gradual and regionally specific. The overall genetic structure of the Dutch population remained intact, suggesting that Viking contacts involved relatively small numbers of people over extended periods. The Viking Age also coincided with important cultural and technological innovations, including improvements in shipbuilding, navigation, and metalworking. But these developments built upon existing Germanic traditions, rather than representing fundamental departures from local practices. Spanish rule in the Netherlands during the 16th and early 17th centuries represented one of the most politically significant episodes in Dutch history, but its genetic impact was surprisingly minimal. Despite over a century of Spanish administration and military presence, genetic studies reveal virtually no detectable Spanish contribution to the modern Dutch gene pool. This finding challenges popular assumptions about the demographic impact of political conquest. The Spanish ruled the Netherlands as a distant imperial power rather than a colonizing population. Spanish administrators, soldiers, and clergy remained a small elite that maintained social and cultural separation from the local population. Religious differences played a crucial role in maintaining genetic separation. Catholic Spanish officials and Protestant Dutch subjects inhabited parallel social worlds, with limited intermarriage or cultural integration. The long struggle for independence further reinforced these boundaries, making Spanish-Dutch genetic exchange both socially difficult and politically dangerous. The genetic evidence also illuminates the nature of early modern European imperialism. Political control didn't necessarily require demographic transformation, and sophisticated administrative systems could maintain authority without fundamental population changes. This pattern would repeat during other periods of foreign rule, demonstrating the resilience of Dutch genetic identity even under conditions of political subjugation. Contemporary genetic studies have provided definitive answers to questions about Dutch ancestry that have puzzled historians and genealogists for generations. Modern Dutch mitochondrial DNA distributions show approximately H at 45%, U at 16%, T at 14%, J at 11%, K at 10%. These frequencies tell the story of Dutch genetic history in remarkable detail. The DNA has spoken, and its message is unmistakable. The Dutch are the direct descendants of peoples who have called the Netherlands home for over 5,000 years, maintaining their identity through countless challenges and changes. In a world where ancient identities often seem fragile and temporary, the Dutch genetic story offers hope that some things can indeed endure across the vast expanses of time.